So now we have exercise 3.3 in here. So it says we need to find the transpose of each of the following matrices. So the first one goes like, it's a column matrix, right? Because why it's column matrix? Because it has only one column. So we need to do the transpose of that column matrix. So question number 1 1. So if I do the transpose, now one thing we know, in transpose what happens is that the row becomes a column and the column becomes a row. So interchange of rows and columns. So here we have the column 1 in here. So this column 1 will now become what? Row 1. This column 1 will become row 1, and there is only one column, so we will have only one row. So basically the column vector will become a column matrix will become a row matrix. So here the answer will go like 5 half minus 1. So this is the transpose of the given matrix. Then question number 2, you just do it yourself. Then question number 3. So question number 3 will be, so if I have to do the transpose of this one, so I'm going to first write this thing, minus 1 5 6 root 3 5 6 2 3 minus 1. So if I have to do the transpose, so I'm going to write here T. So row 1, so row 1 is which one? So this one is my row 1, so it becomes column 1 now. So we have minus 1 5 6. Now the row 2 is this one, so it becomes column 2 now, root 3 5 6, and the next one is 2 3 minus 1. So this is the transpose we got. So this is how we do transpose of any given matrix. Now question number 2. So question number 2, what I'm going to do is I'm going to do any one of them, and you have to do the other one. So I'm going to do question number 2. So what do we have? A is given, B is given. So first let's start with the question number 2. We have A minus B whole transpose is equal to A transpose minus B transpose. So if you're going to start with LHS, left hand side. So left hand side what we have is, first we need to find A minus B. A minus B. What is that? A minus B is equal to, so it will be minus 1 2 3 5 7 9 minus 2 1 1. I'm going to subtract this one with minus 4 1 minus 5 1 2 0 1 3 1. So if I do the subtraction, what we get is minus 1 minus of minus 4 becomes what? Plus 4. So minus 1 plus 4 is 3. 2 minus 1, that is 1. 3 minus of minus 5, that is 3 plus 5, that is 8. 5 minus 1, 4. 7 minus 2, 5. 9 minus 0, 9. Minus 2 minus 1, that is minus 3. 1 minus 3, minus 2. 1 minus 1, 0. So this is how we get A minus B. Now we have to do the transpose of this thing. So A minus B transpose will be equal to what? So A minus B transpose will be, we'll just have to interchange the rows and columns. So my first row is 3 1 8. So now it becomes the column. So it becomes, it becomes column 1 3 1 8. Then we have 4 5 9. Then we have minus 3 minus 2 0. So that's it. This is how we do A minus B complement. Now we have to do the right hand side. So for the right hand side we have to do A complement and then B complement. So for that one we need to find A complement first. So A complement will be what? We can see that this is my A. This is my A. So A complement will be, again the row 1 is what? Minus 1 2 3. So it will become column 1 minus 1 2 3. Then we have 5 7 9. Then we have minus 2 1 1. So this is my A complement. Then B complement will be equal to, which one is my B? This one is my B. So B complement will be, the row 1 of B is minus 4 1 minus 5. So minus 4 1 minus 5. Here we have 1 2 0 1 3 1. So this is how we do this. Now we're going to subtract this 2. So what we get is A complement minus B complement, that is equal to how much? So if I subtract, corresponding elements get subtracted. -1 with -4. -1 minus of -4. That gives us, okay, let me just write those things. So here we're going to subtract a complement minus with, we're going to subtract with b complement. So here we have the b complement. Now if I subtract these two, what do we get? So -1 minus of -4, that gives us +4, so that is 3. 5 minus 1, 4. -2 minus 1, that is -3. Then we have 2 minus 1, 1. 7 minus 2, 5. 1 minus 3, -2. 3 minus of -5, that is 8. 9 minus 0, 9. 1 minus 1, 0. So this is your a complement minus b complement. So now let us check whether this matches with the left hand side or not. Yes, it matches. So I'm going to write is equal to left hand side. So hence proved. So this is how we solve this type of questions. Okay, question number 2 is done. So what you do is, so question number 3, I think you can do it very well by yourself, because again the same thing we have to do. So just one thing I will show you. In here they have given a complement, so you have to keep note of that. In here they have given a complement. So here a will be equal to what? So what will be a equal to? So a will be equal to, we have the first row as 3 4, so it will become 3 4 as my column 1. Then -1 2, then 0 1. So this will be my the complement of a complement. So in order to find a, we need to do the complement of this thing again. So that's why complement of a complement is equal to a. So basically if I have to write this thing, I'm going to write like this: complement of a complement. One second, let me just erase this one and write it well. So we have complement of a complement, and that is nothing but, this is the value of a. Okay, this one is a. And the same goes if I have to find b complement. So what will be the value of b complement? B complement will be, row 1 is -1 2 1. That's my row 1. So it will become my column 1 now, -1 2 1. And this one will become 1 2 3. So this is how we get the b complement and a from the above matrices. And you cannot solve this thing plus minus thing you have to do. So you can do it yourself. Okay. So let's move on to the next question. So in here we have a complement is -2 3 1 1 2, and b is -1 0 1 2, and we have to find the value of a plus 2b. So let's try to do this one. The first thing in question number 4, we have to do a plus 2b. So what is a plus 2b? So I'm going to write, I don't have a in here. So since I don't have a, so I need to find a. So a will be equal to what? So a is equal to a complement whole complement. So we need to do the complement of that thing. -2 3 1 2. So here this is my row 1. So it will become -2 3 1 2. So this is how we got the value of a. Now we're going to put it in the above expression, that is a plus 2b. So a is -2 1 3 2, sorry, plus 2, and b is equal to how much? -1 0 1 2. So that's my b. Now let's add them up and see what we get. So here we have -2 1 3 2, and if I multiply with 2, I get -2 0 2 4. Now add and see what we get. So we have here -2 plus -2, that is -4. 1 plus 0 is 1. 3 plus 2 is 5. And 4 plus 2 is 6. So this is the value of a plus 2b. But we don't stop here. We need to find a plus 2b complement. And that will be equal to what? The complement, sorry, not complement, transpose. The transpose of this thing is what? The row becomes the column. So we have here -4 1 5 6. So this is how we do the transpose. Okay, so that's how we do question number 4. Okay, let's do question number 5. 5, 1 I will do, 2 will be for homework for you guys to try. So I'm gonna do question number 1, 5, 1. So 5, 1, what do we have? The value of A is given by 1 minus 4, 3. A is equal to 1 minus 4, 3. And the value of B is given by minus 1, 2, 1. So this is the value of A and B that has been given. Achha, sorry. B is a row matrix, so it's not a column matrix. Minus 1. So we already discussed that row matrix is a matrix in which we have only one row. So B is the row matrix because it has one row, and A is the column matrix because it has one column. So we need to prove AB complement, AB whole complement is equal to B complement A complement. This is this expression we came across while we are doing the properties of transpose. I'm sorry, every single time I'm saying complement. Actually it's not complement, it's transpose. Okay, तो ये जो एक्सप्रेशन है ये हम लोग पहले देख चुके हैं प्रॉपर्टीज़ में, और मैं उस टाइम पे बोला था कि इसको जब प्रॉब्लम्स करेंगे तब इसको डिस्कस करेंगे. सो नाउ व्हाट वी हैव ए बी होल कॉम्प्लीमेंट. तो इन ऑर्डर टू फाइंड ए बी होल कॉम्प्लीमेंट फर्स्ट वी नीड टू गेट ए बी. तो पहले तो मुझे ए बी निकालना है. तो ए बी क्या हो जाएगा? तो ए बी विल बी द प्रोडक्ट ऑफ 1 minus 4 3 एंड देन वी हैव minus 1 2 1. तो फर्स्ट मुझे चेक करना है क्या मैट्रिक्स मल्टीप्लिकेशन पॉसिबल है कि नहीं. तो ए का ऑर्डर क्या है? द ऑर्डर ऑफ ए इज 3 rows आर देयर एंड 1 column इज देयर, 3 cross 1. और ऑर्डर ऑफ बी इज व्हाट? इट इज 1 cross 3. इट इज 1 cross 3. सो 3 cross 1 एंड 1 cross 3, इफ आई सर्कल दीज टू इक्वल है, उसका मतलब मैट्रिक्स मल्टीप्लिकेशन पॉसिबल है. अब मैट्रिक्स मल्टीप्लिकेशन तो पॉसिबल हुआ, अब दो मैट्रिक्स को मल्टीप्लाई करने के एक मैट्रिक्स ही निकलेगा. तो वो जो मैट्रिक्स होगा, द मैट्रिक्स विच आई विल गेट आफ्टर मल्टीप्लाइंग दोज टू मैट्रिसेस, द मैट्रिक्स विल हैव द ऑर्डर ऑफ 3 cross 3. जो प्रोडक्ट मैट्रिक्स होगा उसका ऑर्डर हो जाएगा 3 cross 3. ये 3 cross 3 कहाँ से मिला? ये बाहर में जो 3 3 है उनको यूज करके 3 cross 3 विल बी द ऑर्डर ऑफ द प्रोडक्ट मैट्रिक्स. तो जल्दी से 3 cross 3, तो एक रफ में क्या करेंगे, 3 cross 3 एक मैट्रिक्स बना लेंगे. 3 cross 3 का मतलब 3 rows and 3 columns will be there. So we have A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is what we have, 3 cross 3 matrix. So now what we are going to do is, अब जल्दी से हम लोग एक एक करके वैल्यू निकालेंगे. A11, तो A11 इसका वैल्यू कैसे निकलेगा? The value of A11 will get A11. It means what? First row, first column. So what I'm going to do is I'm going to pick the first row of the first matrix and the first column of the second matrix. तो अब corresponding element को multiply करूंगा. लेकिन यहाँ पर easy बात ये है क्योंकि यहाँ पर सिर्फ एक ही element है. तो 1 into minus 1 that gives us minus 1. Okay. Now the next thing is A12. For this one, first row, second column means 1 into 2, that is 2. Then A13 is first row, third column, that is 1 into 1 is 1. A21 is second row, first column, minus 4 into minus 1, that is 4. Then we have minus 4 into 2, that is minus 8. Minus 4 into 1, that is minus 4. Then 3 into minus 1, minus 3. 3 into 2, that is 6. And 3 into 1, we have 3. So this is how we get AB. Now we have to find AB complement. So AB whole complement will be equal to, just interchange the row and columns. So my first row is minus 1 2 1, so it becomes minus 1 2 1 4 minus 8 minus 4 minus 3 6 3. So this is what we get, our AB complement. Now next thing what we need to do is we need to find B complement and A complement to do the right hand side. So this one was left hand side. So in order to do the right hand side we need to find the value of B complement. So B complement will be equal to how much? So B complement will be, this one was my B. When we have multiplied B, so AB, so this one was my B. Now we have to do the again transpose of this thing. So we have minus 1 2 1. So the transpose of that thing will become it is entire row. The entire row will become entire column. So we have minus 1, 2, 1. So this is how we get B transpose. Now we need to find A transpose. So A transpose will be what? It will be the transpose of the A matrix. So it is entire. It's a column matrix. So we need to transform into a row matrix. So it will become 1 minus 4, 3. So this is how we get. Now we need to multiply A transpose into B transpose. So A transpose into B transpose, it becomes what? So first you need to write this thing. Now if you check, it is almost same like before, the orders of the two matrices. So it is now 3 cross 1 and this one is now 1 cross 3. Now matrix multiplication is possible, and same as previous one, we will be getting a 3 cross 3 matrix in here. We are going to get a 3 cross 3 matrix in here because the outsides are 3 and 3. Now I hope you guys can realize that. So what we're going to multiply for the first element is first row, first column. So you just fix the first row. First row is fixed. So minus 1 into 1 is minus 1. Now you fix the first row. So minus 1 into minus 4. What do you do? Plus 4. Minus 1 into 3, that is minus 3. So when you fix the first row, you will get only the first row elements. You will get the first row elements. Now first row is finished because it's a 3 cross 3. So first row is finished. Now we'll go to the second row. So second row, 2 into 1 is 2. 2 into minus 4 is minus 8. 2 into 3 is 6. Now second row is finished. Now we'll move on to the third row. 1 into 1 is 1. 1 into minus 4 is minus 4. And 1 into 3 is 3. So this is how we get the matrix multiplication, and if you check carefully, both are equal. That is nothing but equal to AB whole complement. So hence proved. So this is how we solve this question. So 5-1 will be, 5-2 be the homework for you guys. Okay, let's do question number 6 now. So question number 6, what we have is, if A is equal to cos alpha sin alpha minus sin alpha cos alpha, then verify A complement A is equal to I. So first of all, what will be this I? This I is an identity matrix, but we need to know what will be the order of this I. The first thing, let us find out A complement A. So A complement. So what is that A complement equal to? Just complement this one. First row, it becomes first column. So cos alpha sin alpha minus sin alpha cos alpha. This is your A complement. Now we have to multiply this one with A. So A complement A is equal to cos alpha minus sin alpha cos alpha. It gets multiplied with cos alpha sin alpha minus sin alpha cos alpha. Now if you check the order of the matrix, this one is 2 cross 2. This one is also 2 cross 2. So if you multiply 2 cross 2 with 2 cross 2, already we can see that matrix multiplication is possible. Now what are the outside numbers? This one is 2 and this one is 2. So you will get the products matrix as the order 2 cross 2. So how do we multiply this one? The first thing, again, you just fix the row 1. Now this one is difficult than the previous ones because previous one we had only one element, but here we have two elements. So first row with first column. So what do we get? Cos alpha into cos alpha. That becomes cos square alpha. Then minus sin alpha minus sin alpha. So that becomes plus sin square alpha. Just multiply the corresponding elements. Now once you have the first row fixed, now the first row with second column. Cos alpha sin alpha minus sin alpha cos alpha. So the first row is done because it's a 2 cross 2 matrix. So first row is finished. It will have 2 rows. Then we have, I will check the second row, sin alpha cos alpha, and I will multiply the second row. Now I will multiply the second row with the first column. So what do I get? Sin alpha cos alpha, then minus cos alpha sin alpha. This is what we get. Then second row with the second column. So we have sin square alpha plus cos square alpha. So this is how we multiply. So by trigonometric identity we know this one is 1 and this thing gets cancelled, so it is 0. This one also gets cancelled, it's 0, and this one is 1. So it is nothing but identity matrix I, and it is of order 2. So identity matrix is a matrix in which all the diagonal elements are 1 and the non-diagonal elements are 0. So that is what identity matrix is all about. Okay, question number 6 is done. Question number 6.2 will be homework for you guys. So you can do it as homework. It is exactly same as that one. Now let's do question number 7. 7.1. So 7.1, what we have is, show that the matrix A is a symmetric matrix. So we need to prove that the given matrix A, that is A that is given by 1, minus 1, 5, minus 1, 2, 1, 5, 1, 3. We need to prove that the matrix given in here is a symmetric matrix. Now in order to prove this one, what do we know? We know one thing about symmetric matrix is that the transpose of a matrix will be the matrix itself. So if I do the transpose of this one, and if I get that A matrix again, so then this matrix is a symmetric matrix. So for this one, I will find A transpose. So what do we get? The transpose of it. This one is your row 1. So it will become column 1, minus 1, 5, minus 1, 2, 1, 5, 1, 3. So if you look carefully, it is nothing but the matrix A. So I'm going to write since A transpose is equal to A, so A is a symmetric matrix. That's how we do it. So 7.1. Now 7.2. Now it says show that the matrix A is a skew symmetric matrix. Now we have to prove that the matrix given in the second question is a skew symmetric matrix. So one thing I know about skew symmetric matrix, that if you do the transpose of that matrix, you will get minus A as the answer. So here A is given by 0, 1, minus 1, minus 1, 0, 1, and 1, minus 1, 0. Now if I do the transpose of this thing, so what do we get? So the transpose of this one, the row becomes the column. So this is my row, it becomes the column now. So 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. Now if you look here, the difference between these two is that all the numbers which are positive, they are now negative. So what we're going to do is, we're going to take a minus sign common. So if we take a minus sign common, all the elements which are negative in here will become positive, and all the elements which are positive, they will become negative. So 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. Now if we compare with it A, so you will get this one as minus A. This one is minus A. And then we're going to write since A transpose is equal to minus A, so the matrix is a skew symmetric matrix. So let me just, so I'm going to write here since A transpose is equal to minus A, so A is a skew symmetric matrix. So this is how we prove whether a matrix is a symmetric or skew symmetric matrix. Now we have question number 8. So here what we say is, here they have given for a matrix A 1, 5, 6, 7. So we have been given a matrix 1, 5, 6, 7, and you have to verify that A plus A transpose is a symmetric matrix. So we need to verify that A plus A transpose is a symmetric matrix. So for that, first thing, let us find out A transpose. So A transpose will be equal to what? A transpose will be equal to 1, 6, 5, 7. This is my A transpose. Now we are doing A plus A transpose. So A plus A transpose gives us how much? I'm just adding those two. So 1 plus 1 plus 1 gets us 2. 5 plus 6, 11. 6 plus 5, 11. And 7 plus 7, that is 14. So this is how we get A plus A transpose. Now in order to prove this one to be symmetric, what we're going to do is, we're going to transpose of this one. So A plus A transpose whole transpose. Basically, in order to check whether a matrix is symmetric or not, what we need to do is we just need to do the transpose of that matrix. If that matrix is equal to A is a symmetric matrix, but if that matrix is equal to minus A, the matrix is a skew symmetric matrix. So here we're going to transpose A plus A transpose. So A plus A transpose is what? 2, 11, 11, 14. Now this one is my row, so it will become column 2, 11, 11, 14. So this is nothing but the same matrix, that is A plus A transpose. So I'm going to write, since A plus A transpose whole transpose is equal to A plus A transpose, so A plus A transpose is a symmetric matrix. So this one is a symmetric matrix. Now we're going to do A minus A transpose. So if you do A minus A transpose and see what you get. So A minus A transpose, that will be equal to what? So I'm doing subtraction now. 1 minus 1 becomes 0. 5 minus 6 minus 1. 6 minus 5, 1. And 7 minus 7 is 0. You see here, 1 minus 1, 0. 5 minus 6 minus 1. 6 minus 5 is 1. And 7 minus 7 is 0. So now, again, we have to find the transpose of this one, because in order to check skew symmetric, we have to do the transpose. So A minus A transpose whole transpose becomes, my row is this one, it becomes column. So we have 0 minus 1, 1, 0. Now if we compare both of them, the negative elements becomes positive, the positive elements becomes negative. So what we're going to do is we're going to take a minus common. So we have 0 minus 1, 1, 0. Now it is nothing but it is minus A plus A transpose. It is A plus A transpose. So this proves that the given matrix A plus A transpose represents the skew symmetric matrix. Okay, that's verified. So यहाँ पर लिखूंगा मैं, therefore एक second, therefore A plus A transpose is a skew symmetric matrix. That proves it. Okay. Okay, now we're gonna do question number 9. So question number 9. So what we found out from question number 8 is that for any matrix, if you do A plus A transpose, you will get a symmetric matrix, and if you do A minus A transpose, you will get a skew symmetric matrix. But in question number 9, we have to what? We have to find half of A plus A transpose and half of A minus A transpose. So first thing, A is given as, here A is given as, first I'm going to write the question number, it's 0AB minus A0C, 0AB minus A0C, and then we have minus B minus C 0, minus B minus C 0. तो ये A का value है. Then what I'm going to do is I'm going to find the transpose of this thing. So A transpose will be equal to what? तो इसको transpose करेंगे तो क्या होगा? 0AB, ये column बन जाएगा, minus A 0C minus B minus C 0. So this is how we get A transpose. Now after getting that A transpose, we need to find half of A plus A transpose. Half of A plus A transpose मुझे निकालना है. तो half of A plus A transpose क्या हो जाएगा? half. अब मैं क्या करूँगा? Now we're going to write that A plus A transpose. So first we're going to have A in here. यहाँ पर A. Then we're going to do plus. We're going to have A transpose. So half of A plus A transpose, and see what we get. So we have half. Now if we add 0 plus 0 is 0. A minus A is 0. B minus B is 0. So I think every single terms becomes 0. So it is nothing but 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is what we get, half of A plus A transpose. Now we're going to do half of A minus A transpose. Half of A minus A transpose. This is all we need to find. So for this one what we need to do is copy, yeah, so A minus A transpose. So what we have in here, so this becomes what? So look at very carefully. So we have half, okay, this one will be plus sign, sorry, it will be minus sign. So subtract 0 minus 0, obviously it has to be 0. Then we have A minus of minus A, so it becomes 2A. A minus of minus A means A plus A, that is 2A. Then B minus of minus B, that is 2B. Then we have minus A minus of A, so we have minus 2A, then we have 0. Then C minus of minus C, that is 2C. Then minus B, then we have what? Then you see minus B minus of B. So we have minus B, that is minus 2B. And then we have minus C minus of C. So we have minus 2C. And here we have 0. So this is your half A minus A transpose. So we found out the value. I think we haven't been told to do anything anymore. So just this two value we need to find, and that's it. Okay. Now let's do question number 10. So for question number 10, we need to understand what the question said is, express the following matrices as the sum of symmetric and skew symmetric matrices. So we need to express the four matrices given in here as the sum of symmetric and skew symmetric matrix. Now this one already I have discussed that any matrix A can be expressed as half of A plus A transpose plus half of A minus A transpose. So this is how we express any matrix. Now this A plus A transpose, this one means symmetric, and A minus A transpose represents skew symmetric. Okay, so you need to remember that thing. So this is how we express any given matrix as a sum of symmetric and skew symmetric matrix. So let me just do question number 1, 10, 1. Okay, wait a second. Yep. So we have 10, 1 in here. So what is that? 3, 5, 1 minus 1. So 3, 5, 1 minus 1. So let us take this one as A. So let A is equal to 3, 5, 1 minus 1. Then we need to find A transpose, because we will be doing A plus A transpose and A minus A transpose. So for that we need to find A transpose. So A transpose will be equal to what? 3, 5 is the row. It will become the column. 1 minus 1. So this is how you get A transpose. Now we're going to write, therefore A is equal to half of A plus A transpose plus half of A minus A transpose. Okay. So half of, now A plus A transpose, that is how much? That is, I'm going to write these matrices. So here we have A, here we have A, and here we have A transpose. So we're going to add them up, plus, now we have half plus half A minus A transpose. So now we are just going to subtract these two. Wait a second. So in place of plus in here, I will just put a minus sign. So this is how we express any given matrix in terms and as a sum of symmetric and skew symmetric matrix. So what we're going to do is, we're going to write here half, just add them up and see what do we get. 3 plus 3, that is 6. Then 5 plus 1, that is also 6. Then we have 1 plus 5 is 6, and minus 1, that is minus 2. So this is what we get. And this side plus half, this one what we get is 3 minus 3, that is 0. 5 minus 1, that is 4. And 1 minus 5, that is minus 4. And minus 1 plus 1. Minus 1 plus 1, that is 0. So this is how you just leave the answer. So this is how we express any matrix as a sum of symmetric and skew symmetric matrix. So this is the portion which represents the symmetric, and this is the portion which represents the skew symmetric. But if you add them up now, you will get the same matrix again. You will get the same matrix, that is A again. So you just leave the answer like this. So this is how we represent any given matrix as a sum of symmetric and skew symmetric matrix. Okay, now question number 10. We're gonna do 10-2. Let's do 10-2. So what we have, I'm gonna write here, let A is equal to, so A will be 6 minus 2, 2. 6 minus 2, 2. Then we have minus 2, 3, minus 1. Minus 2, 3, minus 1. And then 2 minus 1, 3. So this is what we get. So that's my A. Now we need to find A transpose. A transpose is equal to, so the row becomes the column. This is my row. So now it becomes what? It becomes 6 minus 2, 2. Minus 2, 3, minus 1. 2 minus 1, 3. So this is how it becomes the transpose of A. Now obviously, so I'm going to write here, therefore A is equal to half of A plus A transpose plus half of A minus A transpose. So it becomes what? Half, 1 second. So A plus A transpose, that is how much? So A, this one is my A, plus we have to do A transpose now, half of A plus A transpose, then plus half of A minus A transpose. So I'm going to do okay, I think we don't have space in here. Wait a second, we have to just push it a little down in here. Yep. So what we're gonna do is we're gonna write here half like this. Okay, so now we're gonna add these up. So let's find out fast. So what we get in here is equal to half of, so we are adding now 6 plus 6, that is 12, minus 4 minus 4, 6 minus 2, 4 minus 2, 6. So this is what we get, and then plus half of this side, it will become, oh, this is minus, sorry, this can't be plus, I've copied, yeah, minus. So 6 minus 6 is 0, minus 2, then minus 2 plus 2, that is also 0, 2 minus 2 is 0, minus 2 plus 2 is 0, 3 minus 3 is 0, minus 1, 0, 0, 0, 0. So basically 0 matrix is both symmetric as well as skew-symmetric matrix. Because what is the condition for symmetric matrix? The condition for symmetric matrix is these two must be equal. These pairings must be equal for symmetric matrix. And what is the condition for skew-symmetric matrix? That they must be of opposite sign. Now 0 is neither positive nor negative. So 0 matrix is both symmetric matrix as well as skew-symmetric matrix. So this is how we express any given matrix as a sum of symmetric and skew-symmetric matrix. Okay, now the next two what we have in here, you just try it yourself. It will be as homework. Okay, next question what we have here, it says if A and B are symmetric matrices, of same order, then AB minus BA is a, options are given, which one of them? So it says that A and B are symmetric matrices. So one thing we can say that here they are talking about symmetric matrix, skew-symmetric matrix. So if they are talking about that thing, we know to check whether a matrix is symmetric or not, what we do? We just do the transpose of this thing. So what we're going to do is we're going to transpose AB and AB minus B, we're going to do the transpose of that thing. Now in the properties of transpose, we have studied that AB whole transpose is equal to A transpose plus B transpose. So now we're going to write this one as AB transpose minus BA transpose. Then we know one thing, again another property of this transpose, we have studied that AB whole transpose is B transpose A transpose. So we're going to write this one as B transpose A transpose minus, so BA transpose will become what? It will become A transpose B transpose. Okay. Now in the question it says that A and B are symmetric matrices. So if A and B are symmetric matrices, so it means A transpose is equal to A and B transpose is equal to B. They are symmetric matrices. So we can write BA minus AB. BA minus AB. Now if you compare these two, AB minus BA and BA minus AB. So to make it AB minus BA, we can take minus common and we make it AB minus BA. So what we see is that the transpose of AB minus BA is nothing but minus of AB minus BA. So it means the given matrix is a skew symmetric matrix. Okay. Now what we're going to do is, now we have the question number 12. So that's the solution of question number 11. So question number 12, here A is given as cos alpha minus sin alpha, then sin alpha, and we have cos alpha. So this is my A, and then A plus A transpose, then A plus A transpose is equal to I. So they have told you this thing, that A is given as cos alpha minus sin alpha, then sin alpha and cos alpha, and you have A plus A transpose is equal to I. The first thing, let us find out A transpose. So A transpose is equal to what? It is cos alpha minus sin alpha, cos alpha. Okay, now add them up. So if I add A plus A transpose, that will become what? It will become cos alpha plus cos alpha. So you get 2 cos alpha minus sin alpha plus sin alpha. It becomes, okay, let me write those. Let me write those like this. One second. So here we have this one plus this. So what do we have? Cos alpha plus cos alpha, that comes out to be 2 cos alpha, and then minus sin alpha plus sin alpha, that becomes 0, and sin alpha minus sin alpha, that is also 0, and cos alpha plus cos alpha, that is 2 cos alpha. Okay, now in the question it says that A plus A transpose is equal to I. So what we're going to write is, since A plus A transpose is equal to I, and obviously that I will be an identity matrix of order 2. So we have 2 cos alpha 0, 0, 2 cos alpha is equal to 1, 0, 0, 1. So this is what we get. So from here we're going to write, since the two matrices are equal, so their corresponding elements are also equal. So what are we going to write? 2 cos alpha is equal to 1. So therefore cos alpha is equal to half. So if cos alpha is equal to half, for what value cos is half? So that is pi by 3, that is 60 degree. So here the answer will be option number B. Okay, so that's it. We have